So Obama's talking about all of this with the global warming and that, and a lot of it's a hoax. It's a hoax.
Everyone's been wrong. They've said mass extinction, we're all going to be underwater, ice age, heat wave. No one's ever been right.
I'm wondering, Ben, why you believe that climate change is not an emergency.
Okay, because they're wrong.
Do these guys really know what they're talking about? This group of 4 young students from Chinese International School decided to find out with an investigation.
Global warming is obviously a problem, but we want to know why this happens. And so we decided to study methane, one of the primary substances that causes global warming. Methane has an empirical formula CH4, with 1 carbon atom surrounded by 4 hydrogen atoms. It is a colorless and odorless and natural gas that is naturally produced in plants, in animals via flatulence, and in landfills.
Okay, so where does methane come from? There are a couple of examples. So for plants, they absorb and produce methane. And in animals, during their digestive process, for example, cows fart, that releases methane into the atmosphere. And in landfills, there are lots of methane-producing bacteria. So when they're decomposing the trash, they release methane. And lastly, in melting ice, there's lots of gases trapped inside. So when ice melts, these gases, including methane, is released into the atmosphere.
The question was, why is methane bad for the atmosphere? We gotta start off by saying it's not necessarily bad. It's part of all the gases in the air. It's necessary to help keep the earth warm. But what makes it bad? There's too much of it right now, which contributes to the greenhouse effect, which causes our temperatures to rise and results in global warming, which causes negative effects to the environment. And that's why too much of it is bad.
So the team sets up an experiment to demonstrate the greenhouse gas effect of methane. Their idea was to heat up 3 bottles of gas, first methane, second air, and third oxygen, and to compare the increase in the temperatures of each one, thereby demonstrating that methane would get much hotter. Let's hear from them.
So we have the light here heating up the 3 gases.
On the left side, it's air, in the middle it's methane, and on the right side it's O2. The one on the left represents methane, the one in the middle represents air. The one on the right represents pure oxygen gas, which is O2.
The expected result would be methane. It has the highest temperature.
The team patiently waits for their results to materialize and watch as the temperatures increase. However, the initial progress is slow and the team quickly grows frustrated. The atmosphere is tense as the team continues to wait. Eventually, though, the results of the experiment begin to take shape. The conclusions are clear and the team is excited.
Alright, so as you can see, we're 9 minutes in, and it appears that methane is 33.9 degrees, which is a bit higher than all of the other bottles here.
They watch on, keen to discover if the results will hold up for the rest of the experiment. They do, and the team is ecstatic.
Okay, so at this point, it has been around 30 minutes, and the heat gain is roughly equivalent to the heat lost to surroundings. And that's why the temperature rise of methane, the air, and the oxygen are roughly similar. Therefore, we're going to end the experiment right now.
The team rejoices as they successfully had demonstrated the greenhouse gas effect of methane.
So what's happening in the lab there? Methane is the molecule CH4, in which 4 hydrogen atoms are bonded to 1 central carbon atom. These bonds happen to also be able to absorb certain kinds of light. So essentially what's going on with our world here is that we have sunlight that goes through the atmosphere. After that, some of this light is being absorbed into the ground while the rest is being reflected back into space. What happens is, in our atmosphere, some greenhouse gases are present. And some of the light that is of a certain type will not be absorbed by the bonds and will simply pass straight through the atmosphere back into space, while other types of light will then be absorbed by the bonds. The energy from this light that is being absorbed into the bonds turns into heat, and that's when the world begins to heat up around us. That's why when we have too much of these gases, this effect begins to happen more and more until the world gets too hot for us to live in.
And there we have it. The team makes a convincing case, both explaining and demonstrating how methane gas affects our atmosphere and, by extension, our environment in a scientific manner. Many thanks to team members Alexander Arnold, Alan Au, Audrey Chan and Zoe Zheng on this project. We'll see you next time.